Hello, everyone. Thank you so much for joining us today. We are Pittsburgh Java user group. We do have a meetup page where you can find where you can find. Can you still hear me?
Yeah, we can hear you. Cut out a little bit.
Yeah, that's what I could feel that I got cut out. Anyway, you can learn more about our JUG at the Pittsburgh Java meetup page and more about our events. We also have a Twitter account if you have a Twitter account to follow us there. All of our recordings are up on our YouTube channel, so do subscribe so you get notification of the recorded versions of these meetup events. And we would like to thank our official sponsors, JFrog and PNY Mellon. And with that, I want to hand it off to Rodrigo. And Rodrigo, please introduce yourself and you can take it away.
All right. Thank you very much, Sirisha.
Yeah.
Right. Good evening, everyone, or depending where you are. Glad to see you here. So today we're going to be talking about batch applications. Okay. You don't need to copy now the link to the repository where the code is. I'm going to show you at the end of the presentation. You're going to have access to everything. Oh, I'm not sharing the screen, so yeah. Of course you cannot get anything now. So let's try again. All right. Yeah. So you don't need to copy this right now. Okay, you're going to have access to everything at the end of the presentation. And please, if you have questions, I think you feel free to ask questions when you have it. I'm going to leave the chat open here, so if you have any questions, go ahead and ask the chat or unmute yourself. Ask. I don't know how you prefer to work, Sirisha.
Either works. If you're okay with questions in the middle, then that's fine with us. But we will monitor the chat as well for you, Rodrigo. Perfect. And we can always unmute and ask the question.
All right. Thank you very much. Yeah. All right. So quick intro. So my name is Rodrigo Graciano. I'm a Java champion. I am a director of engineering at Bank of New York Mellon. Sirisha is my colleague at Bank of New York Mellon. Both of us, we are members of the GCP executive committee representing the BNY Mellon. So for those who doesn't know, the GCP is the board that votes on changes to the Java language. So we're both members representing the Bank of New York Mellon. Programming Java since 1998. I'm one of the leaders of the JUG of New York. So Sirisha, part of the Pittsburgh, I'm part of the JUG of New York. So thank you for handling the invitation. Here on my blog and Twitter, you're going to have also access to that at the end of the presentation. So don't need you to copy now, right? All right. So if please use the chat. I just want to have an idea if any of you is using Spring Batch today, or if you're doing any sort of batch processing in your company. And for batch processing can be, I don't know, any task that you need to do, I don't know, every week, every day, maybe a report that you need to generate to your manager, an Excel file that you do that you perform some action. So anything, or if you're using Spring Batch, just curious. Shall not use Spring Batch. All right. I'll keep going and I'll look at the chat. So Spring Batch, as the name says, is part of the Spring umbrella. Okay, it's a lightweight framework. It's a very simple architecture. It's ideally to work with a finite amount of data, and we're gonna talk about this later as well. But I want to mention that if you know exactly the amount of data that you need to process, Spring Batch can be a very powerful tool. If you don't know, there is support, but I think there are some limitations, and we're going to be seeing during the presentation. Right. And Spring Batch is also not a scheduler. So if you're looking for a scheduler, there are other options in the market. You can use, I don't know, Spring Scheduler, cron jobs, a bunch of other things. So Spring Batch is not a scheduler. This picture represents let's see, an overview of the Spring Batch architectures. Okay, so it's going to be something very simple. So we have these main components: a job launcher, a job, a step, a job repository. And the way that works is that a job launcher, as the name says, is going to be responsible for triggering a job. Okay, and one job can have 1 to multiple steps. Okay, important to say that. And for a job, we can say, let's say we have a task. Okay, our task is, oh no, every day I'm going to receive one file, and I need to copy to process this file, filter, and persist to the database. So think as this is your job. So okay, so you're going to have, in this case, only one step. Very often a step is represented by a reader, an optional processor, and a writer. Okay, so in the case you have a job where, example, you need to read from the database, insert in another table, then another step you get from this table and you merge with another one and write to the database. Then in this case, we have one job with 2 steps, being the first step, read and write to the database. The second step is getting from the database and writing to a file. Okay, so just keep in mind, one job can have multiple steps. At the bottom of all of this is the job repository. And as the name says, it's the persistence layer for Spring Batch. So everything we do, we are processing a job, the status of a job, how many items were processed, if there was any error, so many stats about the processment is going to be part of the job repository. It's also important because the job repository, if you need to restart your job failed and you need to restart for some reason, the job repository will have the information when the job stopped, what caused the stop, and we can resume from that point on. Okay, so everything we do with Spring Batch, the job repository is going to be persisted on the job repository. Okay, let's start to see some code. So very simple example to show how Spring Batch works. Okay, so Spring Batch is a dependency, maybe dependency. The last version, if I'm not wrong, is 5.1. Okay, and we can write a job using just a few lines of code. So in this case, we're just creating a job that's gonna read from a file and write from a file. And you can see here that we have about 20 lines of codes, and this is all we need to do this process. Okay. Okay, so here in the top, we are defining a job, and the job we can build using a job builder, giving a name for this job and a job repository. So we just mentioned the job repository. So it's going to be part of all the steps here. Okay. Later, we're going to explain how this job repository, how we can generate a job repository, okay, how we can instantiate one. But just keep in mind that for now, we'll pass this to the job. And we say, here's the job, my name of my job, and I'm starting with the simple step. Okay, this is the step that we're going to process. We're going to see that this step here is defined here. So the same way you have a job builder, we have a step builder. We're passing a name here to the step and also the job repository. We are saying that this step is going to read a field set, which is a batch object, and we're going to write a field set, okay, in chunks of 100 items. Also a transaction manager that we're passing here. A reader and a writer and a build. Okay, so we're defining, so we define the job. We're defining that this job has one step, and this step will have one reader, one writer. Okay, I mentioned before that we can have a processor, but processors are optional on Spring Batch. The reader, we're gonna see that Spring Batch has many readers and writers out of the box, so we don't need to worry about reinventing the wheel and writing them all over again. So in this case, we're gonna use a flat file item reader. So there's for many types of files that we have, CSV, delimited, that can be used. So we're saying that we're gonna use a flat file item reader. We're passing a resource, so the file that we want to read, we're saying that's delimited, so it's a CSV file. And we're mapping the rows using a field set mapper. And this pass-through means it's not going to do any transformation, just read and pass by. Okay, so it's just going to put on this field set. The field set, you can think it's like an array. So we read, And the same way we have the flat file item reader, we have a flat file item writer. Okay, so in this case, we're saying that we're going to read from the input file, and then we're going to write to the output file, also the limited file, and using the same, instead of the field mapper, the field extractor. We're going to see that in this case, we're not doing any transformation, and the result generated would be the same files. Okay, so we're pretty much just getting everything from the input file and writing on the output file. So I know that it doesn't do much, but just to show how in a few lines of code, we're able to process, generate this with Spring Batch, okay? Right. For this presentation, I just want you to focus that we are gonna be working on this table here, okay? So I created this table rental. It has an ID, which is auto-incremented. It's a MySQL, title, varchar, ISBN, and user, okay? I have a MySQL running on my computer here, okay, that we're going to see that this table, as I described it before, and we're going to see that we don't have any elements on this table right now, okay? Okay, so let's try to do some. So I created here a few different configurations, so we can look at the different properties of Spring Batch. So I'm using a profile first just to run this, only this class, because I do have other configurations in the project. So if you're familiar with that, that's nothing new, but just to show, we're going to run, and all the runs we're going to have our starting class, our entry point is always the same, and we're just passing the active profile. And what it does, for those who doesn't know, the active profile first, you're going to look for beans that have this profile. Okay, so if there is another profile, it's not going to instantiate. Okay, so we're going to build this job, and you're going to see that exactly the same as we were seeing before. Okay, so we're just buying a new, building a new job here, and we're saying that this job name is first. Okay, and we're going to start the first step. So this being first step is declared here, first step. So we're building this step with the name first step. We're doing in chunks of 2, passing the transaction manager as before, and we have the first reader, first writer. Nothing new so far. The reader, now it's slightly different. So we're gonna, before we saw on the example, we're using a field set, which is an object from Spring Batch, but in this case now we're using this class rental. Okay. And I'm going to show that rental is a record. Okay. So record, it's the first LTS Java version is Java 17 to have records. So this project is using Java 17. So just think that records are final structures. It's pretty much like a final class. There are no setters on records. And behind the scenes, this is going to generate equals hash code to a string for you. Okay, so you're going to use this rental to represent our object. Okay. So you're going to see that we're going to read from a file, and I'm passing here the resource file. I'm going to show which one it's going to see. And we're saying that's going to be delimited, and I'm going to read the title, ISBN, and user from this file. And I'm going to map using the record field set mapper. Okay, before we saw that we had a field set mapper. This one is a record field set mapper, is the automagic from Spring. So Spring is going to read this, and it's going to generate, it's going to set the values on this record, on the field set mapper. Sorry, using the record field set mapper is going to instantiate the rental class and we're going to insert there. So the names on the properties here, they need to match with the properties on our record class. Okay. All right, and in this case, now we're going to be writing to the database. So we have before we saw the flat file item writer, but this one is going to use a JDBC item writer. Okay, very simple. As long as we have a data source, so we have a data source. My project, so I do have better show, right? So I have the MySQL running. So I have this configuration here on the properties file. URL, username, password. Okay, so I have this property set up here. So with that, Spring Batch, Spring Boot, I have Spring Boot in this project as well. So Spring Boot will generate this data source for me. Okay. All right. So let me close this. Let me go back to batch. Oops. Let me close this. Okay. All right. And one more thing, we're going to be reading this file, very simple file. Okay, only 10 items. CSV, as I said, so we have the title, ISBN, and user. Okay, so CSV, that's the file we're going to be reading. So we have 10 items here. I expected when I run this job, we're going to read the 10 items, map to the rental records, and persist to the rental table. Okay, so we're going to run. This over here. Okay, good. All right, so it says ran and start completed, read the library, and completed with the following status, completed in 1.5 seconds. Okay, so if we go now to our table, and we do a select here. Table. We inserted here 10 items. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So 10 items were inserted all from the table, from the file to the table. Okay. Super simple, but shows that with a few lines of codes, we can active results very quickly using Spring Batch. Right. So moving on, if you have a question, don't feel free to ask, right? Moving on, I mentioned that the job repository is the persist later. And Spring Batch needs to have the schema that's described here to be able to track the job, the steps, and see what's going on. Okay, so when you get the Maven dependency for Spring Batch, you're gonna see that it comes with all the files to generate this schema for a bunch of different databases. Okay, so nothing that you need to do yourself. So you have the schema, you just need to run the schema. Very, very simple. Okay, so here the batch job execution. See, job is going to be tracking the job. So step execution, tracking the step. Okay, so how parameters that we pass to run this job and things like this. Okay, they're going to be all in the job repository. All right, Spring Batch, we can use supports XML or annotations, or the lack of it. We're gonna see why I put that to define your job. So you see that I prefer to use annotations, and you saw that all of our job was annotation based. So we have the annotation, we generated the job, the steps, everything was based on annotation. Okay. Now, one thing that's important is that until the previous, because I'm running here, I have Spring Boot 3 with Spring Batch, the last version of Spring Batch. Okay, until Spring Boot 2, okay, we would need to add this annotation to our class. Okay, to say that we are going to have a batch jobs. And we would do this like in our entry point. So I would just come here and say enable batch processing. Okay, I would do that until Spring Boot 2. I need to do that. When Spring Boot 3 came, they changed this a little bit. And the way it works now is that if you add this annotation, Spring Batch expects you to generate all of those beans yourself. Okay. Again, until Spring Boot 2, if you add this annotation and you have and Spring was able to generate a data source. Okay, so Spring Boot can generate a data source if it has all the properties that to define if it finds on the dependency, let's say on the POM file, it finds the dependency to a database. So in this case, I'll have my SQL. So Spring Boot looks and, oh, okay, I see that you have my SQL. I see that you have the properties here defined. So I'm going to instantiate and create a data source for you. So Spring Boot can do that. So if Spring finds that you have this dependency, all these things, it will generate all those beans for you. So job repository, job launcher, job registry, explorer, operator, and the platform manager is missing here, but it generates a platform manager as well. Okay, so we saw that we need those beans to run the job, but Spring Boot combined with Spring Batch, they will generate these beans for you. Again, starting on Spring Boot 3, Spring Boot, if you see its annotation, expects that you are going to generate them yourself as part of your application. So those are not going to be generated by default for you. Just keep that in mind. All right. So the step that we saw before, it was I would say a chunk-oriented step. Okay, so a chunk-oriented step is going to start with a reader, an optional processor, and a writer. Okay, but very frequently we have some tasks that they do not fit in this model. Okay, for example, if we want to download the files from S3 before we want to process, or we receive the files in a zip format and we want to unzip before we do it. Okay, so for all those cases, there is the concept of a tasklet step. And the tasklet step is that when you want to do a one-time job, okay, or one-time task. Okay, so we define a tasklet with a class that implements tasklets. How surprising, okay? And here we define our business logic. So here in this case, this code would just delete everything that exists on the user temp files. Okay? Simple as that, all right? So we want to do a one-time task. We implement a tasklet. We create our business logic, and that's how we do it, right? One time. Readers. Okay, if I'm going too fast, too slow, just let me know. Something not clear, let me know. Readers. We have so far we saw that one type of reader only. We saw the flat file reader, item reader. But Spring Batch provides out of the box many other types. So we can read from the database. So we have the JDBC connector, Mongo connector, Neo4j, Hibernate. We can work with flat files like we saw before, so delimited, fixed length. We have readers for XML, JSON, JMS, Kafka, AMQP, multifile. So I want to open a parenthesis here. At the beginning of the presentation, I said that Spring Batch is very useful to work with when you have a finite amount of data. Okay, so when you know exactly the amount of data that you're going to read. Okay, but if you look here, JMS, Kafka, AMQP, they do not exactly fit this model. Okay, so the way that Spring Batch would work in this case is going to say, oh, give me, I don't know, you pass an amount of seconds that you want this connection to be consuming data, and after that is going to pass to the writer. Okay, I think that's a horrible idea, right? Because we don't know if all the data was sent. Okay, if we have more data to send, maybe we don't have any data to send and we're waiting for 30 seconds. Maybe we had 1 million records and we just get a small portion of that. So if you have this, when you have a streaming of data that can always be received, you can always be receiving, I suggest to look for some other tool, but not Spring Batch. Okay, Spring Batch is very good when you have read for a finite amount of data, databases, files. So that's the best scenario for readers. The multi-file is a specialized type of reader. Okay? I have this use case, like we have, suppose you receive a zipped file. Okay, and inside the zipped file, you have, suppose you're going to receive every day. When you unzip this, you're going to have a certain number of files. So one day can be 30 files, one day can be 20, one day can be 1. Okay, but they always gonna have the same format. Okay, so they're gonna have, I don't know, instead of I don't know, name, ID, age, whatever it is, but they have all the same format. In this case, with what we've seen so far, we would need to create one step to work with each file, which would make this a mess to work with. Okay? So this multi-file is a specialized reader for this scenario where you have multiple files with the same format, and we can read them all at once in a single step. Okay, so we're gonna pass, like, I don't know, some form of I don't know, files that start with something, files that has this name, whatever. We define a pattern for the file name, and we're gonna be able to get all those files and process at once. So let's see how that works. So in this case, I'm saying that I'm gonna get everything that's from my class path that starts with lib10. So lib10 starts and end with CSV. So in this case, I have two files here. So I have the one that we saw with 10 items, and another here, lib10.2, with another 10 items. Okay. So I expect this to read all those 10 and proceed to the database. And if we am wrong, we have 10 items right now in our database. Okay. Nothing different on our job. So our job is defined exactly the same, but we just change the name here to multi-file job. Our step is exactly the same. Okay, we have the reader and the writer defined. So we're reading from a file right into the database. The difference now is here. Okay, so we define this multi-resource item reader, and that's the one that we pass here in our step. So multi-file reader. Okay. And this, we're going to say that the resources is the one that we pass by. So everything that starts with lib10 star. And we're going to delegate the reads to the rental file reader, which is the same that we saw in the previous exercise. Okay. So it's got the field set mapper that maps to a record using the record field set mapper, the same number of columns and the type that it works with. So this is going to be like a wrapper around the flat file item reader. So the multi-resource, so it's going to get each file and send to the flat file item reader. Nothing different here either. So we have the writing to the database. So we're going to, so the read populates the object rental that's being passed to the writer, and the writer writes to the database in chunks of 2. Okay, so that's why we have the chunk size 2. I'm going to change here to multi-file. I'm going to run this example. And completed, multi-file. And completed in 1.2 seconds. Okay. It's when I'm not on the Zoom, it does in like 0.1 seconds, something like this, but it's just a little bit heavier now. All right, so if we go here now we do a count, I expect to see 30. All right, 30 it is. So we can see the star, so it inserted again, right? So this it's the same file. So here we have the Tristan Shandy. Probably it's repeating again. So here the Tristan Shandy again. But you saw that it inserted from both the files. Okay.
Rodrigo, I have a question for this.
Sure.
So really the only difference here is that the files need to be of the same type because it's being delegated to the same reader.
Exactly. They need to have the same format.
Same format, but they're split across for whatever reason there is, if they're split across multiple files, the data is in multiple files. So you're okay. So
that's very common practice in the financial companies, right? So instead of sending one file that has, I don't know, 1 gigabyte, 1 terabyte, it splits in multiple files, right? To be able to better control I/O and everything. So okay, so that's a very good use case for this multi-file. One thing here that I want to mention, we saw this chunk size, and this chunk size it says after how many items we're going to persist this data. Okay, so what we write to the database. This number is important, okay, because suppose we have 1 million in our chunk size. So that means that we're going to have 1 million records in memory before we persist. In the case we're persisting to the database, it's 1 million, and when error happens, we're going to have to roll back this transaction, okay? In Spring Batch, depending how it's configured, it's going to retry or do something different. But if it's going to retry, it's going to retry that chunk one by one. Okay, so we have 1 million. And the last one, 999,999, it has an error. It's going to roll back the transaction. It's going to insert one by one and commit to be able to identify which was the problem. Okay. In the other way, right? If we put a chunk size that is too low, 5, for example, 5, 10, 2, and we are processing 1 million records, we're going to be persisting this to the database very often. So the cost of this transaction, we know it's high, right? You open the connection, persist, so it's a high cost. So there is no magic number on how much this chunk size needs to be, but you need to try with different numbers to see what's better for your application. But keep in mind, low is going to create a lot of transactions. Too high, if an error happened, then you need to go back and do one by one. Okay, so you need to try to find what's best for your application. I'm looking here on the chat, Deva, what happens when one error? Oh, yes, I see that. We're gonna see in more details during the presentation. Thanks for the question. Good question. All right. So moving on. The same way that we saw different types of writers so far, we saw the file writer and the JDBC writer, but the same way we have many different types of writers, database, fat files, XML, JSON, email if you want to do it. JMS, Kafka, I don't think that's a totally bad idea to write to JMS, Kafka, whatever. I think reading is more of a problem. So I think that's fine if you want to use them to write to the JMS, Kafka, any messaging solution. Okay. Processors, okay? So we didn't see any processor so far, but the processor is an optional step that sits between the reader and the writer. Okay, so any business logic you want to apply to your object, any transformation you want to apply to your object, any filter you want to apply to your object, they're going to be done on the processor. Okay, so the processor has this signature, item processor, which object I am receiving, which object I'm returning. Okay, they don't need to be the same. Okay, well, I can say that I receive a simple DTO and I return a complex DTO. I receive a field set, I send back a rental record. Okay, so you can do all those kinds of things. To filter one object, we simply say return no. Okay, so what's going to happen? We're going to be reading the objects like one by one, and we send to the processor, reads from the processor. If the processor returns no, it says, I don't care about this item. I want to filter it out, and I'm not going to push this item to my writer. Okay? If you return the object of the type expected, it is going to be pushed down to the writer. Okay, so if you want to do any logic and transformation, I don't know, maybe here you get the data and you need to, I don't know, enrich this data with some data you have on a map that you build when your application started, things like this, you can do all this process. So your business logic goes here, okay? Processor is where they belong. We're going to see later how to create a processor as well. Okay. Listeners, okay? So it's very common that our application, we're going to have to take decisions based on something that happened on our application. Okay, so Spring Batch for these items provide a bunch of different listeners that we can use with a few lines of code. So for example, we have a job execution listener, and there is a before job and an after job listener. So we just need to annotate our methods with before job and after job, okay, to be able to do. So suppose every time my process runs, I want to send an email to my users saying that the process completed, and then I create a listener before after job. I get the status of the job execution. We can be success or failure. And if it's a success, I send an email to my business user and say, hey, the file completed perfectly, no issues. If an error happened, I can then take another action and say, I don't know, I need to notify my support team to take an action. Okay, so we can do this using the listeners. So the same way that we have this listener for the job execution, we have for step execution, the same before and after a step runs. For item read, we have before, after, or when there was an error reading. For the item writer, same before, after, or when there was an error writing the item. For the processor, always also for the chunk, and the skip listener. Okay, so skip, we're gonna see a little bit more later, but when we have an error and we don't care about this error and we just want to skip this object, so we can have with the skip listener to notify us about those things. Okay. Moving on, I mentioned that one job needs to have at least one step, but jobs can have multiple steps. Okay. And by default, these steps are going to be sequential. So we're going to say, hey, I don't know, read this data from a file, write to this staging table. So this is one step. Second step, get from the staging table, merge with another table, write to a file. So that's a second step. By default, steps are going to be sequential. So I complete step 1, success, I move to step 2, success, I move to step 3. Okay, so they are sequential, but they don't need to be. Okay, our steps can be conditional, and this condition can be on some business logic or based on the status of our step. So we can say if the step succeeded, completed, we do something. If the step failed, take another action. Or it can be based on some business logic. I don't know, if it's the first day of the month, do something different. Okay, so that can be based on a business logic. So in this case, it's really like a if else. So step 1 complete, if condition, step 2 else, step 3. Okay, so it's pretty much how it's going to work. So you're going to do or 2 or 3. And one more type of step that we can have is split. Okay, so think, if you don't have any dependency between some of your steps, you can split your processing to speed up your process. Right? So in this case, suppose we have step 1, but step 2 depends on the outcome of the step 1. Okay, so it cannot be split, it needs to be sequential. But step 3 does not depend on step 1 nor on step 2. But step 4 depends on the outcome of both step 2 and 3. So in this case, we can parallelize the step 1 and 2. So they're going to be done here in one thread, and we're going to spin up the step 3 in another thread. After step 3 completed and after step 2 completed, step 4 is going to be executed. That's right, Sirisha. They're going to be executed in parallel, right? So step 1 and 2 are going to be executed in parallel with step 3. But step 4, depending on both of them completing to run. Okay. Let's see how that goes. So we have here our job, very similar to what we saw before, but in this case, we're saying start the first step and after run the second step. Okay, so in this case, we're running them sequentially. Okay, chunk size 500, and here I'm defining my first step. Read the writer on the first step. So it's basically is going to read from the database, read from the file and write to the database. So exactly what we saw before. And the second step we're defining here is going to read from the database and then write to a file. Okay, so read JDBC kernel item reader. So we're going to read from this our table rental. And then we're going to write to a file that here is going to be the multi-step with the date and time txt. Right. So let's just, I mean, just do one thing here. Let's just delete this table, everything from this table, just to be clear. Right. So we don't have anything now. Let's run. So we see that I don't have any other files here. No. All right, so let's run this. Let's change to multi-steps and run. And running step and completed in 849 milliseconds. And now if we're gonna look at the table, I expect to see 10 records now. So 10 records. For the table that we read, and now I also expect to see a file here with the 10 records. So we wrote a file, multi-step with the timestamp. So 646. Oh, I have the. I think I have the filter here. All right, so it wrote. Oh no, I have a. We're just reading names that start with M. Okay, so user starts with M. So let's go back here to the database. So user that starts with M, Mark, Michaela. Okay. So that's why we only see 2 records here. Okay. So we read from the file, wrote to the database. Then the second step, we read from the database and wrote to a file. Okay. And here it is. Multi-step. All right, fault tolerance. So this is gonna answer some questions. Yeah,
there's a question on the. I think Sham wants to ask a question.
Sure.
Hi, good evening. So in the previous code, right, you used a chunk of 500, right? So it is going to process 500 records at the time.
Yes.
That's the meaning of it.
Yeah, that's right. So it was 500 defined here, right? So this step is going to run 500. So, but Spring Batch will understand that there is no more items to be read, and then it's going to say, okay, I'm done here. That's the end of my file. I didn't reach the chunk size, but that's all I have in the file. Okay.
Let's say if there are 2000 records, it will run in 500 chunks, right? 500.
Oh, sorry, I didn't get it. What was the question again?
Let's say if there are 2000 records, right?
Mm-hmm.
So it will run in 500 chunks, right?
Yeah.
Okay. So in the next chunk, you mentioned as a chunk of 2, right? So what does that mean? So there you mentioned as a, what is the difference between that one and this one?
So nothing. It's just what does that mean? Okay, so we read here the file, right, and we wrote to the database. I have 10 items. Okay, if I put the chunk size as 500 as it was, it's going to pretty much read all the items and it's going to get to the 10th records and it's going to see that's nothing more to be processed, and it's going to just push to the writer. Okay, and that's one transaction with all the 10 items. If we put 2 here, every 2 records, it's going to send the data to the writer. Okay, so it's going to commit to the database every 2 items. So we're going to have 5 commits in this table at the end of the process.
Okay, got it. Thank you.
Yeah, and again, just keep in mind that it's costly to open connection, to persist to the database, flush the data. So you need to find a balance between your chunk size. You don't be committing too often to the database, but also if you have a chunk size that's too large, if there is a problem, it's going to roll back and it's going to insert one by one. So you have 1,000 and there is a problem in the last one, is going to do one by one for this chunk of 1,000 items. It's going to try to persist one by one, okay, to eliminate the one that has a problem. All right. Answer your question?
Yes, thank you.
Perfect. All right. I see you, Vijay. We're going to get there. Fault tolerance. Okay. So as before, okay, what will happen if there is an error, right? So as we were seeing here, everything was perfect world, right? So we processed, the format was perfectly fine, and nothing happened, right? But we know that life is not like this, and problems will happen. It's just a matter of when, right? So we know that they will happen. So Spring Batch has a lot of things out of the box to support fault tolerance, okay? And we're gonna see a few of them now. Okay, so let me do one thing. So let's do one thing. I have here a fault tolerant job. I'm gonna run this guy. All right. I'm gonna see something different now. And fail. Okay, project fail. So let's just put up here. It says caused by Spring Framework, incorrect number of tokens, expected 3, actual 2. Okay, so that means that it was expecting to read through 3 records, 3 columns. Okay, but only 2 were found. And then this example is reading from this guy here. So let's see. For example, here we see that only 2 columns available. Here 3. Here only 2 columns available as well. Okay, so then the batch just failed. We don't want to see that, right? We want to be able that our application should be resilient and be able to recover when an error happens. Okay. So in this case, we just ran a regular incrementer, a regular job. We have in this case a job listener. Okay. If we look on the error message, probably we can look at this job listener. So it was a rental job listener. So we use this, and we see that this is a job listener. Okay, so we have a before job. So job is about to start should be printed. Job completed with status S after the job executed. So if we look at the console, oh, not here. This information should be printed somewhere here in the console. Oh, there we go. I saw job completed with status. Okay, so this is what the job would do. I think, let's see if the job is about to run, should be here somewhere as well. Here, job is about to start. Okay, so this is a listener. All right, but there is nothing different here on this job, right? So we just said that was a regular reader, a regular item, a writer like we saw before, and that's it. But we have ways to tell Spring Batch that errors can happen and what we want to do when those errors happen. Okay, so we're gonna see that I have here create a different step that use the same reader and the same writer. It also is gonna use a processor now in this case. So we have this rental processor. And the rental processor is pretty much receiving a rental item. So I say that it implements item processor, receives a rental, returns a rental. And my business logic is if the item hash code mod to 0, return no, so filter out, otherwise send out the rental object. I could just, to uppercase. Okay, so that's pretty much what we're doing here. And going back, we're going to see now a few things different. If our step, so this fault tolerant is at step level. So if we expect that errors can happen, we can annotate our step with this fault tolerance. Okay, this is the first step. And then we can use a bunch of different things to work with errors. One of them is the no rollback. So the no rollback, it says, if the exception that is described here happens, do not roll back the transaction. Okay, and we can be much more granular. We should never do this, right? Exception. We should be much more granular, so we can use this annotation. Skip is gonna say for the exception. Okay, for this type of exception, the exception, I can skip an item up to 5 times. Okay, so I'm like up to 5 errors can happen, and I'm fine with that. But we can retry up to 2 times. So if an error happen, I can retry with that, because suppose sometimes that can be I don't know, some network issues that happen. The database was not up. I don't know, can be different things. So we can say that we want to retry. So in this case, we're saying retry up to 2 times, and we can skip up to 5 items for this step, and we're doing in chunks of 10. Okay. We're also adding listener manually here, so nothing stops us from doing this. Of course, for readability is not good. Do not do that. We can separate this class, right, for reuse and maintainability. I'm just showing here to show that you can do this. So we're using a skip listener. So when we skip an item, we can say if there was an error, we log a message, or just log a message. We also have a listener for the chunk, and also a listener for the item write. So we say, when we're writing, if there is an error, we say an error, we say will persist before persist error. Okay, and there's nothing different with the rest of the things here. Okay, so we're reading from this lib fault tolerance, and we are inserting to the database. Just want to confirm we have 10 items in our database, or 12 items. Okay. Now, you know why we have 12 items on the database? I think I didn't show that. So we have 10 before, and when we run our non-fault tolerant step, the chunk size was 2, but the error was only on the 3rd record. So the first 2, they got persisted to the database. Okay. All right, I'm just gonna drop it here again. Oops, I don't want to see, just to be clear. So we have no items, and now I'm gonna say that instead of using this non-fault tolerant step, I'm gonna use this new step that I just showed you. So let's change here to use the FT step. And we're gonna run the same job again, and it's gonna work on the same file. Okay, now it completed. Status was completed, so it was a success. But it's not very easy to read. But let's see. Oh, how are we logging the data? Oh, we're logging warn. Yeah. Should be logging with info to show, because I have the info here. Okay. Live coding. Be easier to change, right? You know, okay, so this one was info. So this one should have been printed somewhere, but let's just run this again. Just drop it again, select nothing here, just run again. This fault tolerance. Right, so here's starting. Sisha, how are we on time? We're good on time? You're on mute.
Great. I am on mute and talking. Okay. So it is 7 o'clock. I think we should be fine for like maybe another 10 minutes or so. And then because we've been getting questions through the chat, like through the presentation, we should be okay for like.
Perfect. We're gonna be 10 minutes is good enough. All right, so we're gonna see here some of this logging message. So skip it. So this one was a skip an error. So skip error reading line 4, right? What else started? We should have other messages in here as well. Jobs about to start. Okay, so all this information we saw that they were logged here. Job completed. Okay, so those are the listeners. So just to revisit, if we want our jobs to be fault tolerant, our steps, right? Fault tolerance, we can use the retry, the skip, the no rollback. For all these annotations are gonna allow us to work with wrong data, with errors. Okay, we can also tell our step if our step is restartable. So I think there's a restart. Forgot the annotation now. Okay, but we can tell if our steps. Suppose we have multiple steps, and you just want the first step to always run. Okay, so if you have an error with the second step, when you restart your job, you want the first step always to run. So you have a property that we can set as well to say that this step should always run, no matter if already ran before, it should always run again. Okay, so we have this kind of capabilities with Spring Batch. Okay, so Vijay, that is going to be the part that interests you. So there are 5 different ways that we can scale our batch jobs. So one we already saw was the parallel steps, right? So instead of running them sequentially, we can say if there's no dependency, we can split them, and this is going to make them run in separate threads. We have this concept of async processor and async writer, and they are good. The best scenario is when your issue, right, is with the time that you take to process an item. Okay, so whenever the bottleneck is your processor, that's a perfect scenario for that, because instead of what happens if I have like 10 items now, okay, without use the async processor, and my processor, suppose it's going to take 1 minute to write each record. First one minute, then it's going to wait for 1 minute, go to the second one, 1 minute, goes to the third one, 1 minute. Okay, so these 10 chunks are going to take at least 10 minutes to complete. Using the async processor and async writer, we're going to send instead of waiting for the processor, we're going to trigger the processor on another thread, and the writer is going to receive a future, okay, which then is going to unwrap to process when it's ready. Okay, so they always need to be together. So in this case, instead of waiting 1 minute, it's triggered another thread, goes back, and probably instead of taking 10 minutes, it's going to take a little bit over 1 minute to process all this chunk. We can use multi-threading, and we can work with a bunch of different things, and it's very simple to work with them. So suppose here, our first step, we can pretty much just say, create here a task executor. Okay. And I can pass to my step and say, executor, task executor, it's task executor, right? Nothing here. Okay, so we can do that, and then it's going to be use this thread executor. So it's something that can use 4 threads, so it's going to be multi-threading in this case. Okay, that's all we need to do. Okay, and you can pass a bunch of different implementations here for this task executor, thread pool, a bunch of different things you can pass to your step. So that's all we need to do to make it your step multi-threading. Okay. Going back to fault tolerance, we already covered fault tolerance job, scaling, and the last 2, the remote chunking and remote partitioning. And in this case is when you want to split your processing across multiple VMs. Okay, so all the first three, we could use on a single VM. The last two is when you're gonna have like a manager and a bunch of workers, and you want to process them across multiple VMs. The difference is the partition is pretty much think as a Kafka. You're gonna partition by a key, and the remote chunking, we're gonna actually send the data over the wire the part. So and the partition, you don't send the data. You just your workers will have access to the database, and they're gonna see what's going on. The remote chunking, we're gonna send the data over the wire. So it's more IO intensive. So it depends on which one suits you better. But that's a easy way that you can scale your job across multiple VMs. Okay. To finalize, and you're gonna have access to all of this. Is just showing here how to run this job. So I have here Docker running my machine, an instance of MySQL on port 3306. That's how I'm configuring my database. It just explains to you how you can trigger one of the jobs and what it does. So, okay, so we have the first job, multi-file, multi-step, fault-tolerant job. And here you have access to the source codes, my blog, which I publish every Friday, something, a list of articles, Java, JVM related, my Twitter. I'm super active on Twitter, so if you have any questions, anything you want to keep in touch, follow me on Twitter. I'm gonna leave here so you can scan this to get access to the repository. That's what I had to present to you. Questions, comments? You get anything out of this? You didn't get anything? Let me know.
Oh, definitely got a lot out of it. So it was definitely useful to see how all of these come together. I've actually heard about Spring Batch in the past. This is the first time I'm actually seeing it in action. So indeed, it's the title of this presentation makes sense now. So yeah.
Right.
Yeah. I think there is a question on the chat.
Yeah. So Jay, it does not require Spring Boot. Okay. But the Spring Boot, for example, if I'm not using Spring Boot, I would have to generate my my data source manually, and I would have to add this annotation, enable batch processing, and then have to instantiate all of my beans that it needs: a job repository, the job explorer, job operator. So all those I would need to instantiate them by default, and Spring Boot just make it much more easier to work with Spring Batch, but you don't need.
Hello. Yeah, actually, I do have one doubt regarding the skip and retry limit. Can you please show me that code again, where you are mentioning that retry limit, so my doubt is, like, suppose one record is wrong. So for that particular wrong record, do the Spring Batch will try for the couple of times to like access it because the retry limit 2 is mentioned?
Yeah. Yes. So it's going to retry to process that chunk. Okay.
Okay.
And after the retry is going to skip up to a limit. Okay. They don't need to be like here. I'm just for purpose of demonstration, I put exception, but they can be different exceptions. Okay. So you can say, I want to retry. Suppose on your processor, you are consuming data from a web service. Okay. And then, I don't know, something can happen, your web service in this time can be down, right? So you can say, and then, for example, when you cannot connect, you throw an error, I don't know, API not available exception that you define. And then you can say, oh, when I have an API not available exception, I want to retry up to 2 times because that's an error that I can recover from. Okay, so it's more frequently to use the retry with something that's you can recover from without, I don't know, with time. Suppose can be the database was down and then was coming up, an API that was not available. While you is more frequently to use the skip with like errors, like in the file, some business logic, some data, corrupted data. Okay, but you can use them together.
Yes, I got it. Thank you so much. Thank you so much, Rodrigo.
Of course.
Ram, you want to ask your question?
Yeah, thank you. First of all, it's a great presentation. And also the Spring Batch provides in the backend about of 10 to 15 tables, right? Whenever the job runs, they process the details in the tables, right?
Yeah.
But did you integrate any UI with that backend tables for the presentation? Because when you're presenting to the clients, like they want to see whether the batch ran successfully or not, right? So did you integrate anything?
There is a Spring, it's a Spring Data Flow or something that provide the UI. I forgot which one now. Spring Integration, Spring Data Flow. One of them can provide a UI to the user. Okay, which would keep the status of the job. I can't remember which one now, but it does have. Let me see if I can. Maybe you can ask me later on Twitter, and I can look at this for you.
Okay, I will ping you. Thank you.
But it does have.
I think that was the end of our questions as well.
Thank you very much for the
Thank you, Rodrigo, for a great presentation once again.
Yeah, thank you so much. And we'll have the recording up probably in a week or two when we get a chance. Be on our YouTube.
Perfect. Thank you very much again for the
Thank you.
have a good one.
Have a good evening, everyone.
Yeah. Have a good evening, everyone. Bye.
Bye.